Ring Lock Scaffold System. Currently, the commonly used front-wall support systems mainly include scaffold systems with tubular, frame, cap lock, crab, and ring lock. The tubular, frame, cap lock scaffold systems have significant disadvantages in terms of safety and environmental protection, and are gradually being phased out by the market. Our company specializes in the Ring Lock Scaffold system, primarily made from Q3 5 material. The vertical standard, horizontal ledger, and diagonal brace are connected via a connecting disc, resulting in joint stiffness that far exceeds the previous three systems and greatly enhances load-bearing capacity. The use of hot-dip galvanizing allows the ring lock to have a lifespan of up to 20 years. The ring lock has no easy loss components, zero loss, and offers high assembly accuracy and repeat setup and dismantling. It's a safe, green, energy-saving, and environmentally showering scaffold system, widely applied across industry, civil, municipal, and bridge construction, structural support, and decoration in various fields. This support method is now widely used, with maximum assembly heights reaching nearly 60 meters. Main components. The main components of the Ring Lock Scaffold system include vertical standard, horizontal ledger, diagonal brace, adjustable U-head, adjustable jack bases, double-channel steel support beams, galvanized square steel, and aluminum beams. Auxiliary components include cantilever racks, steel pedal, truss pieces, and steel stars. Component specifications: vertical standard, hot-dip galvanized surface treatment, steel grade Q355B, wall thickness of 3.2 mm, diameters of I48.3 mm and I60.3 mm. The length modulus is 0.5 meters. Standard length of 0.5, 1.0, 1.5, 2.0, 2.5 meters, with short vertical standard specifications of 0.25 meters and 0.375 meters for the 48 mm diameter and 0.255 meters and 0.395 meters for the 6 mm diameter. Horizontal ledger. Steel grade SQ235B with hot-dip galvanized surface. Diameter of I48.3 mm. Wall thickness of 2.75 mm. Standard length of 0.3, 0.6, 0.9, 1.2, 1.5, 1.8, 2.1 meters. Diagonal brace. The 42 mm diagonal. Steel grade SQ235. 42 mm diagonal brace is a diameter of 42.4 mm with a wall thickness of 2.75 mm, both with a hot-dip galvanized surface. Common specifications include horizontal protection length be multiplied by vertical projection length, such as 0.6 by 1.5, 0.9 by 1.5, 1.2 by 1.5, etc. 0.6 by 2, 0.9 by 2, 1.2 by 2, 1.5 by 2, 1.8 by 2, 2.1 by 2 meters. Adjustable U-head and jack bases. Made from seamless steel pipe. Steel grade is 20, with a hot-dip galvanized surface. Specifications suitable for I48 and I60 basic type vertical standard. The screw sizes are I38 by 5 and I48 by 6.5 respectively. Double-channel steel support beams. Universal types are number 10 double-channel steel, suitable for 900, 1200 mm spacing for 1350 mm beams and 900, 1200, 1500 mm spacing for 1650 mm beams, all with a galvanized surface. Galvanized square steel. Section size is 50 by 100. Wall thickness is 3 mm. Steel grade is Q235. Aluminum beams. Available is 150 and 185 sizes. Material is 6082T6. Cantilever rack. Divided into two systems, 48 and 60. Surface galvanized. 48 system specifications 0.3, 0.9. 60 system specifications 0.3, 0.6. Steel pedal 1.5 mm 6-strip steel formed by single pass rolling. Surface treated with hull deep galvanizing. Specifications 0.9 meters, 1.2 meters, 1.5 meters, 1.8 meters, 2.1 meters. Steel stairs. Specifications include 720 by 2100 by 2000, 720 by 1800 by 2000, 720 by 1500 by 1500. Construction personnel and equipment. The assembly of the Ring Lock Scaffold system follows a team model, with the number of personnel varying based on the height of the scaffold. The overall staffing is determined by project scale, duration, and follow segment size. During assembly, equipment such as forklifts, tower cranes, and drag cranes are used in the process. Construction process of Ring Lock Scaffold system. Showering scaffold. Preparation at the construction site and pour a concrete base layer. Step 1. Set base height. Locate beam positions and mark vertical standard points. Place adjustable jack bases accordingly. Step 2. Place starting vertical standard on the jack bases and adjust horizontal ledger height per design. Step 3. Install horizontal ledger between two vertical standard and circle. Align horizontally and vertically, and after adjusting, tighten the locking pins. Step 4. Install the first layer vertical standard on the starting vertical standard. Step 5. Connect the second layer horizontal ledger and secure. Step 6. Install the first layer diagonal brace using a spiral connection. Step 7. Extend vertical standard using sleeves to increase height. Step 8. Install double-channel steel support beam components and repeat previous steps until reaching the design height. Place the double C steel beam on the desk on both sides. Insert two short standards into the double C beam, with their discs clamped onto the beam, and connect the two short standards using horizontal bars. Step 9. Install an adjustable U-head. Step 10. Position main and secondary keel and install templates. Step 11. Set up formwork, tie steel bars, and pour concrete. Working scaffold. Step 1. Mark lines and position adjustable jack bases. Step 2. Install the first layer vertical standard, alternating lengths. Step 3. Install the first layer horizontal ledger, ensuring heights and leveled. The height of the first horizontal must not exceed 550 mm, and the exposed length of the base screw must not exceed 300 mm. Step 4. Install bottom steel panels per lift. Step 5. Extend vertical standard. Step 6. Install horizontal ledger according to design spacing. Step 7. Install protective railings and diagonal braces, as well as steel stairs. The outer horizontal are arranged at 500 mm and 1000 mm, and the inner horizontal are arranged at 1000 mm. Vertical diagonal pole installation. Insert the diagonal ball pin into the large hole of the standard disc. Installation of steel stars. The hooks at both ends of the steel stars are fixed to the upper and lower horizontals in the frame passage, and the safety pins are located. Step 8. Expand scaffold construction. Installing pedals, vertical standard, horizontal ledger, diagonal brace, and wall ties as needed. The installation of wall ties should be synchronized with the erection of the frame. Note: workers should wear safety belts when the height exceeds 2 meters during construction. Step 9. Install safety nets. Dismantling process of Ring Lock Scaffolding. Before dismantling the Ring Lock scaffold, the concrete strings must meet the specified standards. Demolition operations should follow the principle of dismantling in the reverse order of installation, starting from the top layer and proceeding downward. Simultaneous dismantling above and below. A string of materials are strictly prohibited. Shoring scaffold. Step 1. Loosen the adjustable U-head. When dismantling a scaffold, first loosen the adjustable U-head. Remove the formwork and secondary beam. Continue downwards only after the formwork and secondary beams have been cleared. Step 2. Remove the primary beams. Take down the primary beams, passing them down layer by layer without throwing. Step 3. Remove the main scaffold structure. Dismantle the main structure from top to bottom sequentially. During this process, the height-to-weight ratio of the remaining structure must now exceed 3, and no components should be thrown. Step 4. Pack and transport. The dismantled materials should be organized and stacked neatly, then transported at designated location using tools like forklifts, completing the scaffold removal. Working scaffold. Step 1. Remove the safety net. Step 2. Remove the diagonal brace. Step 3. Remove the horizontal ledger and vertical standard. Step 4. Remove the steel pedal. Step 5. Remove the steel stars. Step 6. Repeat the above steps until the working scaffold is fully dismantled. After dismantling, organize and pack the scaffold materials into the designated storage area. At this point, the wall scaffold process is complete. Product advantages. Compared to a traditional steel pipe scaffolding, the Ring Lock scaffold offers numerous advantages. Prefabricated installation with simple assembly operations. Hot dip galvanizing significantly increases service life. Modular spacing ensures accuracy in assembly. First assembly speed 3 times faster than ordinary steel pipe scaffolding. strong load-bearing capacity. The 48 system has 3 times the capacity of ordinary steel pipes, and the 60 system has about 6 times. Minimal material loss with no easily misplaced components, with a loss rate of less than 10% compared to ordinary steel pipes. Advantages of our products compared to the other Ring Lock products. Unique connection technology, with sleeves welded to vertical rods but transferring rods through steps of welding direct stress on welds, achieving a load capacity of 20 tons and ensuring connection points remain intact, far exceeding products that directly rely on welds for strength. Longitudinal mold joint technology. Our cross-beam casting joints use longitudinal joint technology, significantly enhancing mechanical performance compared to the market's transverse joint technology, greatly increasing safety. Annealing treatment for joints. All our cast joints undergo an annealing process that requires maintaining high temperatures for 6 to 8 hours before natural cooling, doubling material toughness and reducing the risk of brittle failure, thus improving safety. Step-tab nuts. Our nuts feature 2 sets of interfaces to ensure that both the sleeve and non-sleeve ends of vertical rods fit perfectly, greatly enhancing safety during use. Currently, Ring Lock Scaffolding is widely used across many countries in various fields, including construction, bridges, rail transit, logistics warehouses, and airports. As a leading company in the industry, we are committed to promoting green products and technologies, contributing to safety, efficiency, energy conservation, and environmental protection in the construction industry.